Welcome everybody. My name is Daniel Hickey with Bulldog Tools. Some of the things we're going to do today is success and how to achieve it. Things that we can teach you on technical tips and tricks, cost-effective components, how we can save time as money. But first, we're going to talk a little bit about us and who we are. Bulldog Tools is located in Lewisburg, Ohio. We are about 20 miles east of Dayton, Ohio. Bulldog is a family-owned business. So starting out with the family is the gentleman here on the left is Dennis Meyer. He is the president of Bulldog Tools. The gentleman on your right is Bob Meyer. He is our vice president. Bob and Dennis run our manufacturing plant. And us as a family business, we also have his wife, Michelle Meyer, that runs the office for the shop. As us being a family business, we also do multiple things in this industry, like farming. Bob's brother is an equal VP of Bulldog Tools, but he also runs the farming side of our industry. His wife, Deneen Meyer, also helps Bill with the farming side. So us as the family business, Bob handles all of the manufacturing and Bill handles all the farming side. And if everybody knows anything about Bulldog Tools, we are very proud to say we are American-made products. We are dedicated, even in our farming side, you can see that even in our pastures with our corn and soy that we grow, we even do designs to show the American flag or even recognize our POWs. So as everybody can see, we are very proudly made American products. With our products, we deal with a lot of metal components, locking mechanisms, and a plastic called the Ringmaster. With all of our components, we laser etch everything so you guys can see our logo, the part number, even we stamp with the etching made in the USA. And we've even now put the serial numbers so you guys can use it for tracking. What we're going to talk about today is the Ringmaster. What is the Ringmaster? Some of the things you need to be successful. Again, how to save time and money. Some of the things is an oven that works really good. Products to help laminate plastic processes. How to use the product. Now let's take a closer look on what you need to use the Ringmaster. First thing is the plastic. Our Ringmaster is an injected molded system with a ring internal to help it for support. With our Ringmaster, we offer it in 3 different sizes. We offer it in 12, 16, and 20-inch circumferences. 2 thicknesses, 8.5 and 13 millimeter. With the Ringmaster, we have the injected molded, but now we've even done it with, it has holes and taken the ring out. So we have the red rings with some dowel pins that lock in the plastic. So we offer it 2 ways. With the 2 rings that you can use to hold it in your stand without clamping or bracing, we've even made the stands. Now you have to have the stand for the size plastic that you're pulling. So if you have a 12, 16, or 20, you've got to have each of them stands. We've even gone into making vacuum forming plates with a nice groove for vacuum. Same thing, it's the 3 sizes, 12, 16, and 20. Other things you need to use the Ringmaster is a lamination kit. With the lamination kit, you use the dummy. We have an option with a side bolt or without a side bolt. With the lamination dummy, we recommend using the threaded 4-hole spikes to help your alignment. We've also come up with a center spike that you can thread into it and lock it into your foam or plaster model. Also, another tool is a rubber mallet. Some things that we've seen different people in the industry use plaster to help smooth in the distal end. We've even had some people use modeling clay to help fill the voids and smooth in the lamination dummy. With smoothing it, we've come up with a sculpting stick that you can reuse over and over, again, to save time and money. Same thing as a drill bit that we offer. That's just some of the tools you need to use our Crystal Ringmaster. So now we're on to the step. First thing we're doing, again, Bulldog's always trying to save time, will save money. So you doing that, the Ringmaster is the answer for that. The Ringmaster is a patented round sheet of check socket material. With the material, it saves you time and money on heating and making a very cost-effective check socket. If you look at your Ringmaster, it's an injected molded from the inside out. Being injected, if you look at it nicely, you'll actually see the rings like you do on a tree on how it's injected from the center out for strength. With the strength of this, that's where you get the longevity of lateral walls that are thicker and the strength of a clear check socket. One thing you do not want to do with this is overheat it. You know, the Crystal is a very strong product, but the hotter it gets, the more brittle it can get. So lower temps makes it cook a lot nicer and pull easier and last longer. It is an adjustable type of material for modifications, so a heat gun works very well. When you're all done and cleaned up, I've used a torch to clean up the proximal edge of it and makes it a nice, clear, smooth transition. Any questions at this time? Now, we're going to go to the process of how to use the Ringmaster. First thing you want to do is preheat your oven to about 365 degrees. No two ovens are the same. So infrared to convectional, you're going to have to adjust your temps to where the plastic works the best for your needs. They've come out with thermometers that help checking your ovens and make sure your oven's complete all the way around inside. So, because each oven, especially infrareds, the tubes have different heating elements in certain areas. So you just want to check to get the most efficient part of your oven. Next thing you're going to do is prepare your cast. Make sure it's smooth. Make sure there's no holes or craters in it. Getting ready to add the thermoforming dummy. With the dummy, like I said, you have the 4 adjustable spikes. I recommend only 1 to 2 threads up just to give you an indentation in the distal end of your plastic. If you go too high on it, it forms to cause a crater in the internal side of your check socket. We also can say you can use the 4 spikes on the other side to help hold it, or again, we have that center spike. With the center spike, you have options to help hold it. Again, you can get the 4 to tap it in with your hammer. The center spike helps it lock in very nice so you're not slipping or moving. Once you get the thermoformer dummy on, now you want to have a smooth transition from the dummy to your foam or plaster model. Using this, you're able to use the plumber's putty or plaster to blend it in. Once you've got all that ready to go, now you're ready to pull the Ringmaster. First thing you want to do though is make sure you have a good vacuum between your plaster foam model and the plate. I've seen a lot of people use wood or even excess foam to lift the model up to get a good vacuum. That's why we've come up with the grooved plate so you can set it flat on the plate and give you a good channel underneath your model. Now that you're ready to heat your plastic, you can get by with putting it on a stand at your shop with just 1 red ring and the plastic with the spur facing downward. If you do have to rotate or flip your plastic in your oven, start out with the spur facing upward. Preferably, we like to use 2 rings so you're not handling the plastic with your gloves. It's not getting stuck to your gloves and causing imprints. If you don't have the 2 red rings, it is able to use your old square plate design to help lock it in. I do not recommend putting it straight to your stand. It tends to stick, causes problems, and will not work. Again, Bulldog has designed the whole system to work cost effective with the stand, with the rings, and even in the plastic. Now you're heating your plastic. It takes an average with the oven already preheated, about 15 to 20 minutes of working time. You want to let the project drop about a third to half the length of the model. Again, with that center spur facing downward. Once the check socket is ready, you're able to now pull it out of the oven. Again, we're talking about the center and the spur. The spur is the center portion of your plastic. With that, it allows you to know when you're flipping your plastic onto your model what the dead center of your round ring is. So you can get it on the center of your plaster or foam model on the thermoforming dummy. Recommendations on pulling the plastic. I've recommended as pulling it, you pull it in a circumference of twisting it while you're pushing it down. Again, everybody as a technician does it different. It's your options. While you're pulling it, when you flip it, pull and twist, apply some vacuum. Recommend pulling vacuum in slow so you can work the plastic in to your model so you don't get no creases. Once you get a good vacuum, you let the plastic cool. You're then able to take a screwdriver and tap the ring, and the ring easily removes when it's cooled off. Now, once you've got it cool, now you're ready to cut the ring master off of the model. After you draw your lines, you cut it out. You know, we have some options that we've come up with. We offer the fin cutting tool for cutting out check socket materials. After you've got it cut, now you've got to remove the thermoforming dummy from the job. First thing, you do not want to sand at an angle where you can mess up the check socket. So preferably if you're going to grind out the side bolt, you want to preferably grind downward away from the project. Once you get the side bolt taken out, grinding either across or down, then you want to take the side bolt out. Once you remove the side bolt, you're able to then bust out the plaster or take out the foam. Once you get the foam drill taken out or the plaster, now you can use the long drill bit that you're able to, the 4 indentions that were put in the plastic to be able to get your alignment. Thank you. And if any questions on how to use the Crystal Ring Master, welcome. Today we're going to talk about how to install a top load lock with a 2-stage lamination. First thing, some of the things you need to install a 2-stage lamination. First, top load 3 generation push lock, 3 Gen A-TL. Also, the 65 millimeter thermoforming dummy from the top load lock, the TF-65TL. Also, you're going to need a 4-hole lamination adapter number 13 low profile. That is the FHLA-13. That is some of the stuff you need to fabricate a 2-stage lamination. First thing you're going to do is Vaseline or mold release the 65 millimeter dummy. This allows resin to not get stuck between the surfaces, between the plate. After you do that, you're then going to apply putty to the center hole. That protects resin from getting into the center, pulling it up, and also into the threads, put some Vaseline. Now that you have that all ready and prepped, you want to bolt the 4-hole laminated, the FHLA-13, to the 65 millimeter top load lock dummy. Then fill on the concave portion, the 4 holes with plumber's putty, plus the center spot hole. That allows resin not to get into any of the saturated areas where the threads are going to be on your dummies. Once you get all that put together, you now then want to attach the connected parts to the distal end of the cast. And with that, you want to be able to use plaster or putty to smooth the transition from the thermoforming dummy to the cast or foam model, so there is no lip or grooves on your cast. Once you have everything smooth, now you're able to pull the PVA bag over the cast and tape it around the 65mm dummy. Once you have it taped, you can trim it off and just leave the excess tape from that down in your PVA. With this, you will have the low profile attachment plate exposed for lamination. Once you have that all set up, you now then want to do your layup material. And again, your layup material is whatever you choose at that time on carbon, Nye glass, stockinette, what your preferred use is, setup requirement. When you're pulling it over the attachment plate, you want to do a layover so the plate is exposed on the distal end. I also, again, recommended Vaseline so the laminate, it doesn't stick to it. Once you have that all, you're now able to then pull the PVA bag over the carbon material, and then again use a Yates clamp, tie off the PVA, check your vacuum, make sure you have no pinholes or leaks in your PVA. And that also helps cure your PVA bag. Once that you have the PVA cured, you're now then able to saturate your job with resin and string your model. One thing with this, when you first put in your resin in your PVA, turn your vacuum on and allow the resin to saturate around the distal end. Take your hands and work it around the attachment plate. Make sure you get a good saturation around the attachment plate in your thermoforming dummy area. Once you have that, then string your whole job. When you're stringing your job, we recommend stringing it all in and out, up and down, and at one direction on your final string. When you have that all completed, now you've got to finish up the stage of the first lamination of the job. Now that the resin has cured, you're now able to pull off the PVA bag, then prepare the model for the second stage lamination. There's a lot of different resins out there in this industry. Some of the resins you have to rough up and sand the whole job so you get a mechanical bond to your first stage lamination. If you use some of the different, I guess, epoxies that are out there, they're saying you don't have to rough the jobs up, that you get a chemical bond. So it's your preference of the resins you're using, but if you have to, you rough the whole job up completely so you're able to have a mechanical bond for your resins to be able to stick to the first stage lamination. Once you have that roughed up, you're now able to then put it in your transfer jig to allow to have a two-stage lamination. Once you have it set up in your jig, then you can use another low profile plate. Again, recommending the FHLAP number 13. Then you also want to use the FHLAC. You can screw it to the low profile plate, then put plumber's putty on top of the screw heads. Once you have that plate secured, now you're able then to use a cup or thin plastic or film, something to build a cavern around the shape of your first stage lamination. What this is entirely doing is allowing you to get a shape of foam that you're going to pour into that model. Expanding foam can be flattened while rising on a lamination just by using a cup. Once you have that done, the foam is cured, it's set. Now you can remove the cup or plastic, whatever you used, around the surrounding area. Once you have that area removed, now you can shape and make a transition of your model. Also, at this time, you can remove the putty from the lamination adapter and take the adapter off of the distal end of the plate. Now you have your second stage formed in. Now you're able to then do the second form of your layup. Once you have your carbon stockinette or whatever tied in, then you're able now to complete the final layup of the job. Pull a PVA bag. Again, I recommend tying the PVA bag off with a Yates clamp and allowing it to make sure you have no pinholes. It helps, again, cure the bag a little bit. Once you have that, now you're able to pour your resin into your job. And like the first step, I'm doing the first stage lamination. Work the resin around the distal end, around your attachment plate to make sure you get the air holes out and you got a good saturation. Once you have that done, now you're letting everything dry. Pour your resin in. Now it's curing. Once the resin is completely cured, then you're able to pull off the PVA bag and mark your trim lines. Once you got the trim lines done, now you're able to either knock off the model, break it out of your foam or plaster model. Once you have that, you then remove the 65 thermoforming dummy and replace it with a top load lock. Once removed, it's complete. Remove the plug and silicone from the distal sides and clean out the putty that's down inside the plate. After you have that, sand down the cap, remove all that putty, trim and clean up socket lines. Once you have everything trimmed and clean, you'll have your side bolt hole cut out. Now you can install the 3 Genesis lock. Once you have the lock installed with the top load lock, you're now able to completely assemble your job and build your prosthesis. Thank you. If you have any questions. Now that we've talked about how to use the Crystal Ringmaster, our next process is going to be how to install the APL lock. Some of the things that you need with an APL lock is an adapter plate lock kit with an alignment nut. You also need an adapter plate lock fabrication tool. Another thing is the adapter plate lock tightening tool, and also the dummy removable tool. We also then have the threaded adapter plate for the APL lock square titanium. That is some of the kit that you need to be able to put an APL lock in, the thermoforming dummies. First step is to smooth the APL dummy around the cast. Once you get it smoothed around the cast, you want to place a threaded stud on the lock nut. You can use putty to line the stud up, then assemble the APL dummy on the nipple. Align the groove to the button side of the dummy. If you look on the nut that threads on, there is a slight groove that you can see. You want that to be aligned where the side bolt's going to come out of your fabrication. Once you get that, then you're going to get your material to pull your plastic over the model. When you pull the plastic over the model, make sure you had a good vacuum and it's pulled tight around the APL nut for your inner liner. After you've got that and it's cooled, you now then can assemble the APS-1-AL plate. Prep the threaded set screw mold release on it. Fill the center hole with putty. Get your alignment to where you need it set up. After you have that, then you want to set the plate and fill the voided area. After you get the area filled, you now want to smooth to the inner liner so you have a good transition from the plate to your liner. Once you have the transition of the liner smooth, then you want to cover it with a thin stockinette. This is just primary for a wick for your PVA bag to get a good vacuum. Once you get your PVA pulled over and turn the vacuum on, seal the PVA around the 4 holes attached. After you get all that and the PVA is dried and cured, now you're able to start your lamination process and setting up your materials. Recommendation, we recommend putting a carbon cap just to strengthen the distal end where the APL lock will be. Once you have this carbon cap, then you want to lay up your material that you're using, the carbon, nightglass, whatever materials you're using for your lamination. Once you have the lamination taken care of, you want to again pull another PVA bag over. I also put a Yates clamp and pull vacuum to make sure that there's no holes or anything in your PVA. Once you're satisfied with that, it's secured and sealed. You now then want to mix up your resin and pour it into your PVA. Once you pour your resin in, you're getting a good saturation. You're stringing out your job. Once the job is done and completed, you then want to tie it off, let the carbon cure, tie off the excess resin you have, and let the process cure. Once the resin is cured to 100%, you're now then ready to break it out and cut the cast out. After you break the cast out, you get all the carbon, or I'm sorry, carbon, but plaster out or foam. Now you want to remove the APL dummy from the socket. With that, we have the removing tool that threads down in. You pull the dummy out, and then there's a nut down into the socket where you can take the Allen head out. Once you've done all of that, you're able now to separate the two, remove it from the lamination, the inner liner, clean up, and now get ready for your trim lines. Once you get all the trim lines cleaned, socket cleaned, now you want to be able to finish the carbon frame and your flexible inner. And then once you have your flexible inner trimmed up, clean, your carbon proximal edge cleaned up, now you're able to install the lock. First thing you need is a 13 millimeter socket and an extension. With that, now you want to be able to take it with the tightening tool, the APL-RT, which inserts into the lock that you can thread down into the inner liner. That will then tighten to the lock, the knot that's inside of the inner liner. Once you have it tightened to the socket to the inner liner, line it up the side button to fabricate the hole. Once you have the hole trimmed out, the lock is in place, it's tightened to the nut. Now you can insert the spring back into the APL lock. Then you can slide the inner liner into the laminated socket. Once you have that, now you're able to install the release button. To install the release button, you have to slide it into the lock, push the button in, and then put the set screw inside the socket and tighten that up on the internal side of the APL lock. Once you have all that, now you're able to clean up and build your job for your patient. Thank you. Welcome to Bulldog Tools. Today we're going to talk about how to install a foam cover. Some of the things that you need to install a foam cover is a square foam blank, that 107 PE-W, a tape measure, 1-inch masking tape, a Sharpie, and an ace bandage. First thing you want to do is lay the socket on the side of the foam. Then you want to lay all the way to mark the distal end of the model, and then you want to go up about 3 inches and mark another line on the foam and on your laminated job. Once you have the lines marked on the foam and on the socket, you then want to take your tape measure and measure the circumference of the job, and you want to write it down on the side of the foam. So you want to try to do this from the distal end of your socket, go up about 2-3 inches, mark it again, then go up another 2 or 3 and mark it, have 2 measurements of circumferences to 3 if you can. Once you have the circumferences on the foam on the side, then you want to stand the foam cover up and then make a circle to where you can draw the first from the distal end. You want to have that circle first where you mark it. Would put dots in a circular motion. Once you do that, you then want to connect the dots. That's your distal end mark of circumference. Once you have the distal end, then you go to your next markup. You then again want to repeat with your tape measure, make a circle of the circumference of the shape, put the dots, and then you want to draw them circles. Depends on the length of your model, on how many circles you need to give you a shape for internal carving of your foam. On an average on a BK is 2 marks, and AK is an average of 3. Once you have these done, then you want to go to your router. With them marks that's on the side of your foam with the tape, you then want to mark the tip of your router bit to the last mark on your foam for the distal end. You want to then put a tape around the shaft of the router. That shows you on how deep to hollow out the foam cover on the inside. Once you've done that, you want to go to the next mark and do the same process with the tape from the distal end from that mark it on the router shaft, and so on your marks. Once you have all of that marked, that shows your circumferences and depths that you need for your router to hollow out the internal portion of your foam. Once you have all the markings done, now you're close to being ready to start hollowing out your foam cover. Recommendations in some labs, if you have a vacuum, You can stick a vacuum hose on the distal end of the foam. It allows, when you're hollowing out the foam cover, to suck the foam from inside down through the hole of the foam and not having to worry about it blowing everywhere. Some people just have the vacuums on the side of their stands. That would work too. Now that you've got your vacuum figured out, first thing you want to do is when you turn your router on, grab your foam, go to and shove the foam into it all the way down to your first tape mark that you put on the router. That's the farthest one away. That would give you the depth of the length of your laminated socket or check socket if that's what you're putting in. You want to complete a circular motion till the first black line is taken out, and use that depth the same all the way down into the socket. Once you have that first circumference hauled out all the way down to where the distal end of your socket was, you can again use a tape measure and check it to make sure that you are down all the way to your first mark. Once you get that first mark, then you want to repeat to the second step. Once you have that, where you haul it out to the second tape mark, you also again want to check it for your depth in the socket. Sometimes you're able to try to slide the socket in, but you can see there in the picture that it's not completely all the way down inside the foam. So then what you have to do is then hollow out the foam more to allow that process for the socket to be able to get down into the foam so you have a nice tight fit all the way around. Once you are satisfied with the depth of your hollowing out portion, where you have a nice tight fit for your foam, where your socket is all the way down in it, once you have that, then you can go to your bandsaw, if you have one, and able to trim the squared corners off of this foam blank. If you don't have a bandsaw, people use knives. Just your preferences how you can cut foam. Taking the edges off of the foam allows you, when you use an ace bandage, to pull a nice form tight fit around your model. Once you've got the edges cut, you then can remove the socket. You can take a heat gun, use heat to internal bore. That allows your foam to get soft and flexible internally. Once you have the internal where you're happy, where it's a nice form fit, it's warmed up, then you're able to slide your model back into your job. Then you use the ace bandage and wrap as tight as you can around the foam to your thermoforming job. Once you have it tight and it's cured, a recommendation is a couple hours of this to allow. Preferably, if you let it sit overnight, it even holds a better form of heat, where it keeps it in better shape. When it's cooled, then you're able to then remove everything, attach the foot, and shape your job. Thank you. If you have any questions.